Let's discuss Chapter 9, Section 1 on simple interest. Something to know about simple interest, because we'll talk about a few different kinds of interest accounts from now till the end of the semester. Simple interest is a one-time deposit. We would call that deposit the principal, and also a one-time calculation of interest. So simple interest is the simplest of interest calculations that we'll talk about, and you calculate interest only once during the life of the loan. The formula for simple interest is I equals PRT, which means interest equals principal times rate times time. When we look at rate, we're also always going to look at its decimal equivalent of the percent. And for time is always considered in years. Later on, we'll have examples where we're given something maybe in terms of months or days. And in that case, you would just make it a fraction to have what fractional amount of a year the time is being calculated. To calculate maturity value is the total amount. That's the principal or the original amount that was put into the account, plus the extra interest that the bank is accruing. Kind of think of the interest as the bank's way of paying you back for allowing them to use your money in their investments for the time that your money is at their bank. So the principal is the loan amount, or in terms of a bank account, it's the amount of the deposit. So in a loan, it's the amount you're borrowing. In a bank account, it's the amount of deposit. The interest rate is always written as a decimal, and the length of the loan is written in years. Let's get started. Question 1, we have somebody that borrowed $3,500. That's the principal. 5% simple interest. You will see this word simple interest whenever we're working with the formula for simple interest. 5% is going to be changed to 0.05, the decimal equivalent, and time was given in years. I tend to start out with my formula using variables, and then I'll fill in what I know. The principal was $3,500, the rate as a decimal, and also the time. All of these values are on the same side of the equal sign, so we can multiply them all together. And when we multiply them all together, we get an interest amount of $1,225. To find the maturity value, think of this as the total amount that you have to pay. In this case, if you're borrowing money, the total amount that you have to pay back to the bank. So you have to pay back the principal plus the interest that's accruing. The principal was the original $3,500 that you borrowed, plus the interest that accrued during the time of your loan, $1,225. Putting those together, the total amount you would pay back to the bank is $4,725. Let's try question 2. So James needs to borrow $45,000 for 9 months. So notice that time is not in terms of a year. When we work with those 9 months, we'll make it 9 months out of 12 months of a year. And because we're using a calculator, I'm going to leave it as 9/12, but you could reduce that to 3/4 because there is a reduced value. Okay. So we have our principal. I'm going to put P for principal. We have our time, 9/12, and again, you could change that to 3/4 or its decimal equivalent, 0.75. A friend offered to loan the money at 14.5% simple interest, so we'll change that to its decimal equivalent. We also have a second person offering, so the first one was a bank at 14.5% interest. We also have a second person offering to borrow or allow him to loan the money, and that's at 10% simple interest. So let's look at the 14.5% simple interest and then the 10% simple interest. And again, you'll see me start out with that formula most of the time, finding the interest. The principal was $45,000. In this case, the rate as a decimal would be 0.145, and it is the same if you write 0.145. And we already talked about our time being 9/12. We can put all of this together. If you're trying to do it in one shot on the calculator, 9/12, the fraction bar is a division symbol. So it would be 9 divided by 12. Putting all of this together, multiply 45,000 times 0.145 times 9 divided by 12, and I have $4,893.75. That's the interest on the account. Okay, the amount above and beyond what you're borrowing. Let's find the interest if we're working just with a 10%. So same $45,000 borrowing. Now our rate is changing to 0.10 for 10%, but our time is still the same, 9/12. So remember, this would be the same as above, where that 9/12 is really multiplying by 9 and dividing by 12. And that gives us a simple interest of $3,375. And the last part asks us to find out how much was saved if we're using the 10% loan. So the savings is the difference. And difference means subtract. So we're going to subtract the two different interest amounts. And using the second account, I have that we would save $1,518.75. Let's go ahead and try question 3. Find the number of days from June 3rd to August 16th. I'm going to handle this very similar to how we calculated days in a previous unit. I'm going to write down all the months from June through August. So June will have to calculate some days, July will have to calculate some days, and August will have to calculate some days. So in June, we're only going to use some of the days. There are a total, if you use your knuckles, June is a valley, and there are a total of 30 days in June. But we're not going to use all 30 days because 3 of them were already used. The person coming in for the loan to the bank didn't use those first 3 days. So there's only 27 days left in June. So we want days 4 through the end of the month, 30, including June 4th. In July, we're going to use all the days of July. And in July, there are 31 days. In August, we're only going to use some of the days, but we're going to use the first part of the month. And so we want days 1 through 16. We want the first 16 days. So putting together the 27 days that are at the end of June, the 31 days in July, and the 16 days in August, I have a total of 74 days between June 3rd and August 16th. Let's practice that one more time. Find the number of days from November 8th to February 17th. And you can always pause your video and try it yourself, and then restart the video if you want to give it a try before I start to go through the answer. I'm going to write down all the months from November 8th all the way to February of the next year, so November, December, January of the next year, and February of the next year. In November, we want the end of the month. So we're going to say that there are 30 days total, minus the 8 already used that happened already, and that ends up with 22 days at the end of November. In December, we're going to use all 31 days. In January, we're going to use all 31 days. And in February, we're only going to use the first, the beginning of the month, and we're going to use the first 17 days. Putting all of those together, I get 101 days. We're going to pause this video and we'll pick up again with another video.